Okay, live now. Coming.
Okay, guys. For the ones that are following us from home, sorry about this. We lost connection. It's now our fault. Is the infrastructure fault. And where we were basically was that now we have to write, since we are dealing with nested Cmake list, as I was saying before, we have now to write the Cmake list inside the src folder. Okay, so if you have a look now on the structure of your project, and this is important, here is important, the structure of your project, you will have 4 folders, okay? Data structure, geometry, messages, and utils, okay? 4 folders, random folders. Okay, now you can visualize this better with, for instance, the tree command on the command line. Okay, utils is a bit more populated. Now we have to include the compilable files, only the compilable files, inside our add library and inside the Cmake list, inside the src folder. Okay?
So basically this command, this instruction for Cmake defines a target. Remember the targets of Cmake that can be either shared libraries or executable. And this says, oh, shall there be a target? This target, shall this target be called core library? Right? That's the name. And I want it to be a shared object, or I don't want to have static linking, but you can also blast that shared keyword if you don't want. And then, once you define a target, you have to tell what are the files which are required to generate the target. And the files in this case are all the CPP files in the folder. That's clear? And this will instruct Cmake that each time this target has to be generated, it will have to look at these files, find the dependencies, and so on, and issue a make file with the proper dependencies that then, when called, will compile the library. Clear? So basically, you have to find all the CPP files and list them in the folder.
Yeah, you have many files, but the CPP are not so many. So we'll give you 30 seconds.
You can, if you know a little bit of Unix, you could simply enter in the folder with a terminal. Good. Sure. You can enter in the folder with a terminal. The folder is called, what is it called?
src, yes?
Source. The subfolder was?
The subfolder what? We have 4 subfolder here.
Yeah, well, the one where you were putting the CPP files.
4
library.
subfolder.
Yeah.
We have 4 subfolders.
4 subfolders. You do only one?
Yes.
Oh, okay, you can type ls minus r. No, lr, sorry. ls minus lr. And then oh, no, it sucks.
You can use 3, guys. We have like the 3 command. It's very nice, and you can enjoy this. Yes.
Exactly. And then once you have the 3, you edit it. You eliminate all the lines that don't have a CPP at the end, and more or less you're done. Remember that you don't have to list the H files in the Cmake, only the CPP. Because the H file contain only the definitions. The H file do not generate code. Okay?
I gave you an example of the blob CPP file, okay, which is inside utils. So you can follow pretty much the same thing, go inside every folder and insert your CPP file here.
Of course, if you change the project in the future, and you will do, and if you're going to build your own project, you can repeat the same pattern. You know the layout of the structures, you start building the make files slowly, you know where you put the files, and you can define your target and compile. Exactly what you know. Git blog suited as library. Here you go. Then it's a piece of code.
Ah, penso che... sì, ok.
Stavo testimoni dentro, no?
No, ha detto semplicemente come prendo tutti i CPP.
Ah. Yeah, or you can use the command line of Dennis. No, that's a shell script that he posted on YouTube. On YouTube. Fammi vedere come sta andando.
So for every, sorry, for every C Taskmaster, I just write user or user slash and then tag.
Yes.
Yeah, okay.
Yeah, depending on where it is now. If you open your construction, you see the file which is outside, which
So, all right, in a while, Luca will give you the solution. We see that if you have issues, just post them on the chat. I'm active and willing to solve problems.
Okay, guys, here I am. And if you didn't manage to, this is for everyone. If you didn't manage to complete this little part, I put the code in paste bin. Okay, so if you go to the following URL, you can copy and paste this. Okay, these are all executables that you have, all the CPP files that you have to put inside the ad library.
Or you can use the command that student called Dennis posted in the chat. This is the shell, a small shell script that crawls into the directory tree and extracts the CPP file.
Okay, so do this, and we will go to the last part, which is the generation of the executable.
And I think that from the next exercise, we will switch to Zoom only for the exercises to foster the participation of those that are at home. Because YouTube, the lessons will be on YouTube, and the exercises will be on Zoom. But of course, also, that's always.
Ricordati sempre, tra ogni passaggiato, ricordati sempre di pulire questa prima replica. Quindi fai element replica di fare. Completiamo l'esercizio e poi facciamo l'esercizio. Esatto, no, era quella che è stata. Devi lasciare lo spazio. E l'asterisco vuol dire che non cache. Adesso è finita, dopodiché completa l'esercizio, completa questa parte dell'esercizio. Allora, purtroppo non si vede da qua il link, se lo insomma col browser. Non zooma tutto tranne che... Okay guys, is that pastebin.com/ and then this is the end of the URL. If you go there, you can copy and paste, and we avoid that you make mistakes, so like spelling mistakes, stupid mistakes. Are we done, guys? Did you manage to copy and paste or to write yourself, or the only, like, we have to align ourselves so we can go to the last part? Yeah, I gave the link. If they go to the link, they can copy and paste. Vero, bella nuova. Sembra di essere in Roma. Sì, io c'ho la tremarella. No, 2000, bro. Non è tanta, però. Ieri mi sono a fare l'analisi. Did you manage to finish, guys? Can we move on? Let's move on. Otherwise, okay. So this is what we expect.
The order doesn't really matter, right? The order in which you put the files doesn't really matter because they get compiled together and the system looks inside to figure out which one needs to be compiled first.
So are we ready to build again our package?
The build you always do, the generation of the package you always do from the build directory. So we now generate the make file.
First, always a clean, so we see the output again and again. Yes.
Wait a second. It's hard for me to see you because the screen is
slow. Yeah.
Zoom in.
No.
Zoom.
Oh, sorry. Yes. Yes. I managed to do it. 1 second.
I mean, why don't we work with a shell which is a little bit narrower so that we have more
Because I like to work with my laptop. Okay, so we have our build directory is clean. Okay, we remove all the files that we generated previously, and we can go again with cmake dot. Okay, this is fine.
Luca, can you send again the list of the past bin, or can you show the link of the past bin?
Yes, you have it. Actually,
no.
You can copy and paste it here. Okay. So again, our compiler did not complain.
No, Cmake did not complain.
Cmake did not complain, right?
But we did not build anything. We just generated the files that would then trigger the true compilation.
Exactly.
Okay, so to trigger the true compilation, there will be something to be done.
Yes.
So, for instance, calling make in the build directory.
Should we do this now?
Do it now.
We wait for the new executable. No.
Do it now.
Okay.
Do it now.
Okay.
No, without -j symbol. Okay. And here you see what's going on. You don't see the commands, but you see that actually it's compiling the things one after the other, and at the end you see the linking phase, right? And then presumably in the build directory we will find a file which is a link directory, file which is called core library.
Che cosa vuoi cercare?
La cosa che si chiama core library, il file generato. No, cd punto. Perché io forse hai usato qualcosa, fai find.iname core library, non so dove l'hai messa.
Forse perché ancora non abbiamo generato.
No, l'hai generato.
Sì, abbiamo generato questa qui. Sì. Non so
Punto spazio asterisco punto search.
No, eccola qua.
Okay.
Build as SRC, giusto?
Okay. So like, what happens? Like the question is like, when did you generate the core library? You generated the core library in the folder where the Cmake, by default, in the folder where the Cmake file of the core library was, which was in source. So if you go into the directory build by default, the build directory.
Ci sto già dentro the build directory.
But I can't see because there are a million graphics, you know. The build directory reflects the structure of the source tree. So you have source in the thing and you will have source in the build directory, and then you find finally lib core library. Lib is the prefix that Linux puts to every library. Then there is the target name, and then there is SO, which means shared object, which is a suffix, the extension of the library. Okay? If you type the command file libcore library SO, you see that it's a library. The command file in Unix inspects a file and tells you what sort of object do you have there. It should be an image to tell you, oh, this is an image. Okay? Well, and with this we realize the first target. The interesting bit is that we don't need to know where the library has been put, right? We don't need to know it later on. Because when we will be generating the executable, we will tell a potential executable that will link against that library, so that it includes, say, the functionalities. We will only say, add the target link library, so to generate this target, you have to use this library, and we will call it by name. Which name? The target name. So we will say add executable, main, my name, whatever. So target with all the files, and then we will say target link libraries, my name, and then we will list, in this case, core mini core library or our
core library.
Core library. We don't need to know all these funky names. We just work with the names that we assign to the targets inside Cmake. Is that clear?
Okay, so let's go to the last step. Okay, so which one is the last step? Obviously, if we are building a program, we want to generate an executable, something that we can run, whatever it is. Okay, so like you do in every languages, you will have a main. Okay, this is our executable. Sorry, I zoom it. Okay, in this this is a very stupid executable. We just create objects that are coming from the library that we generated. Okay, so as you can see here, you have all the files.
They don't know C++. So.
I know. So here you can see all the files are coming from, all the files included, okay, are coming from the library that we generated. Okay, messages, data structure is all the files that all the folder that you found here. Now, what we are doing in this stupid executable, you don't have to know what we are doing because it's not relevant for the purpose of this homework. We're just creating objects. Okay, this is a way of creating objects. And then there is a stupid art thingy that will be run after that. Okay? And as I say, this is a main. Now, if we go inside the last Cmake list, okay, we have to insert the commands in order to compile our executable and to generate our executable that we can run. Okay, so now please refer again to the slides of Professor Grisetti of Monday, and you will find the command to generate this executable. Okay, and I'll give you 2 minutes, and then I'll give you the solution, and we finish this homework. Okay.
Remember, the executable is a target, and it's a target of type executable. So target as executable. Target as executable. The dependencies will be defined in the C file containing the folder, the CPP file containing the folder, and the include directories we specified once at the beginning of the Cmake when the portable they include, and the link dependencies of the target is the library that we have just generated.
So the first thing is to add the executable, okay, running the add executable command. So here we specify, like we give the executable a name, a random name, whatever we want. Obviously it should be meaningful in a large library. And then we are saying, okay, bind it to like this CPP file. In our case, our CPP file is called many object in stack example.cpp, okay, which is inside the executable folder. Having said this, we specify link dependencies for the target use. So we say that basically we have to target our library. Okay? This way our target, our executable, is linked against our library, which is the one that we provide the name before in this Cmake list. Okay? Is everyone fine? If you have questions?
I think we have to leave. There's the next one that is
Should be pretty straightforward. So let's do our last thingy. Now basically we populated all the Cmake lists that we had. What we can do is, for the last time, hopefully it will work, we'll create a build director, okay? Or you claim the build director that you created before. Then we run against Cmake. Ottimo. Minicode. Okay, basically I managed to remove everything from, delete everything. Ottimo. Okay, so let's start again. Build, create a build directory. cd build, then Cmake. We detect everything is successful. We don't have error messages. We run make. -j stands for the number of core that we have, so we can speed up the compilation. Okay, much faster compared to the one that you saw before. Okay, we'll build our target. So this is what you have seen in the last compilation, was on linking the library, and now basically we build our target, which is our executable, is what we have to run. Now, where we find the executable? The executable, we find it in this case inside the build directory. Okay, there will be a folder called executables, and in here we find, like, we see the executable is a green one in the command line, is highlighted.
I mean, if you go lower, they see less. Like for the black.
Okay, is this clear? Yes. We have seen already this before on the previous compilation.
Make. Okay.
Okay. You want to see the J, the command?
So we have to put this command in the directory
In the build directory.
Like, don't use too many commands. What Luca wanted to do is to show the power of his machine. The command option -J spawns the compilation on 6 processors, basically, right? So if you want to use more processors and have a faster compilation, you can type make -J with the number of processors that you want. But if you type make, you go single core. Okay, -J without any argument will launch a compilation on all possible cores that you have on your system. Okay?
Basically, we just repeating again the building procedure. Okay, we went inside the build directory. We type cmake space ... We generate the make file. Okay, and then we type make and we build our system. And -J stands just for the number of cores that you have available and you can use. Okay, having said that, now we have, since we inserted our last Cmake list inside the system, we generated our executable. Okay, so the compilation didn't give any error. You may have error of compilation if you type something into the main, or because I didn't put any error. So if you don't have error in the compilation, then you can execute the executables. Okay, and this is the stupid message that I left you, that you have to see in order to certify that this homework is complete.
Okay? For yourself.
For yourself, yes.
Okay, now we have to close the streaming because the pods are pressing. And have a nice rest of the day, and I will have 4 more hours of lesson.
We show this, you don't have to be a master in compilation.
Bye-bye.
Probably...
Next exercise will be on Zoom only, and we will probably record the screen and make it available later, but we will not do it live. So we will do Zoom, a classroom, and then later on the recording will be published.